So imagine a city where the temperature, regularly hits 120 degrees.
Which is just staggering.
Right. And the sky is frequently choked with these blinding dust storms. Like stepping outside your front door feels literally like walking directly into a preheated oven.
Yeah, it's a completely hostile environment.
Exactly. But then imagine that exact same city is globally famous for being the primary food basket of its region.
Cultivating just massive agricultural wealth.
Right. So today, in this deep dive, we are looking at how that impossible contradiction actually works.
Well, it forces us to completely rethink our relationship with the environment.
For sure.
In the materials we're looking at today, we're doing a deep dive into 5 of the world's hottest cities.
And these are places where, extreme heat isn't just an anomaly.
Right, it's not a passing summer heat wave. It is the foundational reality of daily life.
Yeah.
We're looking at populations that don't just endure average daily highs, that rarely dip below 95 degrees, but they somehow build booming economies right in the middle of them.
And for you listening, you know that deeply visceral dread of a hot day.
Oh, absolutely.
You step outside, the sweat immediately beads on your hairline, your shirt clings to your back, and you feel like you are running a marathon inside a hairdryer.
That is a very accurate analogy.
Yeah, and you might debate whether turning on the AC is worth the electricity bill. But in these 5 cities, turning on the AC isn't a financial debate.
No, it's absolute baseline life support.
Exactly. But as we'll see today, plugging in a bigger air conditioner isn't actually how these cities survive.
Far from it. If these places relied strictly on brute forcing the climate with indoor cooling, their societies would collapse.
The power grids would just melt down.
They would.
Yeah.
And stepping outside would be a fatal endeavor. So our goal today is to connect the dots on the actual mechanisms, the architecture, the geography.
And the profound behavioral shifts.
Yes, the shifts that allow human beings to actually thrive in these extremes.
So let's start with 2 places that have essentially engineered their way into the desert. We're talking about Phoenix, Arizona, and Doha, Qatar.
2 globally recognized, rapidly growing metropolitan centers.
Right. Let's look at the baseline numbers, starting with Phoenix. So it sits in the Sonoran Desert of the American Southwest.
And the sources note their winters resemble peak summer in most other parts of the country.
Which is wild. From May to September, the average daily temperature sits above 98 degrees Fahrenheit.
And their summer highs consistently sit between 106 and 110 degrees.
With a record high of 122 degrees.
But the crucial detail about Phoenix isn't just the daytime peak.
Right, it's the nights.
Exactly. The nighttime offers almost zero thermal respite. The city experiences this massive urban heat island effect.
Because all that concrete and asphalt basically acts as a giant thermal battery, right?
Precisely. It spends 14 hours soaking up intense solar radiation. And then when the sun goes down, it slowly bleeds all that stored heat back out into the air.
So the environment never actually resets.
No, it doesn't.
And then you have Doha, the capital of Qatar. It's sitting on the northeastern edge of the Arabian Peninsula right along the Persian Gulf.
And the absolute lowest temperature that city sees all year long is around 71 degrees in January.
That's their winter low.
Right. In peak summer, daily highs consistently surpass 100 degrees.
And they have recorded a staggering temperature of 122.7 degrees Fahrenheit.
Yet, both Phoenix and Doha are just booming. Millions of people are moving there.
Which brings up the core engineering challenge. Like, how do you construct a functional society in a climate that hostile?
It's a massive undertaking.
Because when I read those 122-degree records, building a thriving city in that environment feels like constructing a space station on a hostile planet.
That's actually a great way to look at it.
Who are engineering a bubble in a place that biologically wants to reject you. But let me challenge the narrative here a bit.
Okay, sure.
I know you said they aren't just brute forcing it with AC, but aren't they? Are we just strapping giant Freon units to every building and hoping the grid holds up? Or is there a deeper architectural strategy at play here?
The architectural strategy is actually the only reason the grid does hold up.
Oh, really?
Yeah. In Doha, for instance, they don't just build standard glass skyscrapers that turn into giant greenhouses.
Okay.
They utilize high thermal mass building materials, like specialized limestone.
So explain how that thermal mass actually changes the physical environment for someone living there?
Well, rather than conducting heat directly into the interior of a building, these dense materials absorb the sun's energy incredibly slowly.
Okay, I see.
So throughout the blistering daytime, the stone absorbs the heat, which keeps the interior naturally insulated and much cooler.
Oh, wow.
And by the time the stone is fully saturated with heat, the sun goes down, and it releases that thermal energy into the cooler night air.
That's brilliant.
They also orient the buildings themselves and the narrow alleys between them along specific axes.
To cast shadows, right?
Exactly. To ensure the structures physically cast shadows over pedestrian walkways during peak sunlight hours.
So the city itself acts as a shade canopy.
It does. They're essentially turning the buildings into a passive cooling system.
That makes a lot of sense. And in Phoenix, the material notes a similar intentionality, though focused kind of differently.
Yes.
They are actively combating that asphalt thermal battery we talked about by planting expansive shade canopies using drought-resistant trees.
Right, and implementing highly strategic water management.
Yeah, they aren't just running sprinklers. They are designing the ground absorption to sustain life without draining the desert dry.
It requires an intricate dance with the environment.
Definitely.
But as complex as Phoenix and Doha are, the temperature reading on a thermometer only tells half the story of human survival.
Right.
This brings us to a crucial meteorological concept and a massive difference in the type of heat we're dealing with.
Which means we need to leave the architecture behind for a moment and look at the geography. I want to look at the oppression of moisture.
Yes.
We are transitioning from Doha over to Indio, California, and then to Jizan, Saudi Arabia.
Okay.
So Indio is located in Southern California's Coachella Valley. It averages 99 degrees in midsummer, but holds a terrifying record high of 123 degrees Fahrenheit.
Which is incredibly hot.
But Indio is defined by cloudless skies and bone-dry desert air.
Right, so the sun is beating down relentlessly with zero atmospheric filter, but the air contains almost no water vapor.
Exactly. And then we pivot to Jizan, Saudi Arabia. It sits along the southwestern coast on the Red Sea.
Right.
Summer highs average above 95 degrees, occasionally hitting 116 degrees. But unlike Indio, Jizan, much like Doha on the Persian Gulf, is a coastal city sitting right next to a massive body of very warm water.
And the geography here becomes the primary adversary.
Now, wait. I've always heard the phrase, well, it's a dry heat, used as a joke to make places like Arizona or inland California sound better than they are.
Right. The classic trope.
But like it's a crisp oven instead of a swamp. But physically, 123 degrees in Indio just mathematically has to be deadlier than 95 degrees on the coast in Jizan.
You would think so.
Because water naturally cools things down. You get ocean breezes. Doesn't coastal proximity make the heat more survivable?
You would naturally assume so, but the physics of human survival actually run in the exact opposite direction.
Wait, really?
Yeah. Coastal water in these extreme temperature zones is a brutal liability.
How so?
To understand why 95 degrees in Jizan is often more lethal than 123 degrees in Indio, we have to talk about wet bulb temperature.
Wet bulb temperature. I see this term popping up more and more in climate discussions, but what exactly does it measure?
It is the ultimate scientific metric for human survivability. Standard thermometers just measure ambient heat, but wet bulb temperature measures heat alongside humidity.
Oh, I see.
It essentially calculates how well water can evaporate in the current air conditions.
Okay, so why is that so important?
Well, this is critical because human beings survive extreme heat in exactly one way. We sweat.
Right.
But sweating itself doesn't cool you down.
It doesn't.
No, the evaporation of that sweat off your skin is what pulls the heat away from your body.
Let me see if I can put a visual on this for the listener. Think of the air around you like a sponge.
Okay, I like that.
In a place like Indio, the air is a bone-dry sponge. So when your body sweats, that dry air instantly soaks up the moisture, rapidly pulling the heat away from your skin.
Yeah.
You're losing water quickly, but your core temperature is being regulated.
That is a perfect way to visualize it.
Good.
But in Jizan, or Doha, the intense solar radiation is beating down on the Red Sea and the Persian Gulf, right?
Right.
Causing massive amounts of warm ocean water to evaporate, so the air becomes completely saturated with humidity.
So the coastal air is a sponge that has already been soaking in a bucket of water.
Exactly.
It can't absorb a single drop more.
Exactly. Zero evaporation can happen. If the wet bulb temperature hits 95 degrees, meaning the ambient temperature and the humidity combine to prevent any evaporative cooling, your sweat just pools on your skin,
Oh, man.
trapping the heat inside you. At a wet bulb temperature of 95 degrees, even a perfectly healthy human being resting in the shade, with unlimited drinking water, will die in about 6 hours.
Wow.
The thermodynamic limits of the human body are simply breached. Your core temperature rises until your organs fail.
That is deeply unsettling.
It is.
So the hairdryer is blowing, but the air is fully saturated. That completely flips the script on how we usually think about coastal cities.
Completely.
95 degrees in Jizan is a localized steam room that literally shuts down human biology, whereas 123 degrees in Indio is undeniably dangerous, but your sweat still works.
Exactly. Your body still has a fighting chance at temperature regulation.
The coastal water doesn't provide a cooling breeze.
No, it provides the mechanism that disables your body's only defense system.
That's wild. So if a coastal city like Jizan is basically a giant steam room where human sweat fails, and a place like Indio is a 123-degree oven, you would naturally assume these lands are completely barren.
Right, just endless stretches of scorched sand and rock.
Exactly. But nature has a weird way of exploiting exactly what human biology hates.
It really does.
That steam room. It turns out to be the perfect greenhouse.
Yes.
Which brings us to the most surprising twist in our sources, honestly. These specific inhospitable cities are actually massive agricultural and cultural hubs.
This is where extreme adaptation moves beyond just surviving and into active cultivation.
Okay, tell me more.
Let's look at Shri-Ganganagар in India. It's located in the northwestern state of Rajasthan, near the India-Pakistan border.
Right, sitting squarely in the Thar Desert region.
Exactly. The baseline metrics here are staggering. It averages above 101 degrees from April all the way through September.
And a record high of 120.9 degrees recently recorded in 2025. Plus, frequent blinding dust storms throughout May and June.
It sounds like a post-apocalyptic wasteland.
It really does. Yet, our sources highlight that Shri-Ganganagар is proudly known as the food basket of Rajasthan. Like, how does that happen? Dust storms and 120-degree heat do not equal a flourishing farm.
Well, they didn't just plant seeds in the sand and hope for the best. Human engineering intervened on a massive scale.
Okay.
With the creation of the Ganga Canal.
Yeah.
They didn't just bring in a little drinking water. They artificially altered the water table of the Thar Desert.
Consider the sheer scale of that.
Yeah.
They took the desert's greatest liability, the absolutely relentless, punishing solar radiation, and turned it into an asset.
Precisely. Because plants need sunlight for photosynthesis and water for nourishment.
Right.
The Thar Desert provides maximum unfiltered solar radiation. By engineering the Ganga Canal to provide a hyper-controlled hydration system, they essentially turned a hostile desert into an optimized open-air hydroponic farm.
That is incredible. So the heat isn't a barrier anymore. It's the engine of their agriculture.
Exactly.
Which suddenly makes the situation in Jizan make perfect sense.
How so?
Well, we just established that the coastal humidity in Jizan creates a wet bulb nightmare for human beings. It shuts down our ability to cool off.
Right.
But that exact same thick, humid, 116-degree air creates the perfect tropical greenhouse conditions for agriculture.
It does.
The sources called Jizan a vital port and an agricultural center referred to as the fruit basket of the region. They produce huge yields of mangoes and tropical fruits.
It's fascinating, right? What kills human comfort grows a perfect tropical fruit.
It's a masterclass in exploiting unique geographical features.
And the adaptations aren't just agricultural. They are deeply behavioral.
Oh.
Yeah. In places like Shri-Ganganagар, the society doesn't just push through the peak heat. They completely shift their daily routines.
Okay, so they change when they do things.
Right. The active hours of the city move to the early morning and late evening, avoiding the sun entirely.
A complete recalibration of how a society tells time.
Exactly.
And we see a different kind of exploitation in Indio, California.
Right. The festivals.
Yeah. Indio is globally famous for hosting massive outdoor music and arts festivals. We're talking about drawing hundreds of thousands of people into a desert that hits 123 degrees.
Which sounds like a recipe for disaster.
Right. If you have 100,000 people in a crowd, the thermodynamics are usually a nightmare. How are people attending outdoor festivals under that kind of sun?
Well, they utilize the extreme predictability of their climate.
Okay.
Because Indio is defined by that dry, cloudless heat we discussed earlier, the weather is incredibly consistent.
So no surprises.
Right, it allows for highly controlled logistical environments.
Because they know it's not going to suddenly rain or become overwhelmingly humid, event organizers can build the infrastructure entirely around shade and hydration.
Exactly. And because the air is dry, evaporative cooling techniques like those giant misting pavilions are incredibly effective.
Oh, because the mist actually evaporates and cools the crowd.
Yes, which wouldn't work at all in a humid place like Jizan.
Right. It would just make it worse.
It proves that extreme environments don't prohibit thriving communities, provided you deeply understand the physics of your local climate.
And have the resources to adapt your infrastructure to match it.
Exactly.
So let's bring all of this together because we have covered a massive amount of ground today.
We really have.
We've looked at 5 cities that completely redefine the limits of human habitation. We started with the engineered megacities of Phoenix and Doha,
Where high thermal mass architecture and calculated urban shadows keep the power grids from melting down.
right? And then we explored the terrifying reality of wet bulb temperatures, where a humid 95 degrees in coastal Джизан can be vastly more dangerous than a bone-dry 123 degrees in Indio.
And we saw how populations pivot to turn those exact extremes into advantages.
Yeah, whether it is utilizing the Ganga Canal to build an open-air hydroponic food basket in the 120.9-degree Thar Desert,
Or using the Red Sea's suffocating humidity to grow vast crops of tropical mangoes.
which is a huge takeaway for you listening. The next time you step out into the summer heat and you feel that first bead of sweat hit your hairline and you immediately scramble back inside to the AC.
You now have a global perspective.
Exactly. You know exactly what it takes for millions of people to navigate temperatures that regularly top 100 degrees, not as a crisis, but as a normal Tuesday.
Right. It isn't just about enduring the heat.
No, it requires an intricate mix of advanced thermodynamics, architectural ingenuity, and profound behavioral shifts.
And, analyzing these cities leaves us with a highly provocative question about the future.
What's that?
Well, right now, these specific, localized cities are forced to shift their daily routines to off-peak hours.
Yeah.
They have to completely redesign their building materials, their urban layouts, and their water systems just to exist. But as global temperatures continue to rise, what happens when this isn't just a localized desert issue?
Oh, man.
What will the concept of a normal 9-to-5 workday or a traditional city layout look like for the rest of the world if extreme 100-degree heat becomes the new global baseline?
That's a scary thought. Like, if the wet bulb temperatures start rising everywhere, do we all become nocturnal?
It's a real possibility.
Does the glass skyscraper become completely obsolete? It is a fascinating and slightly terrifying reality to consider.
It definitely is.
But until that day comes, at least we know the mechanics of how the experts survive it. Just remember, the next time you feel like you're running a marathon inside a hairdryer.
Somewhere out there, somebody's using that exact same hairdryer to grow a perfect mango.